the chain rule. What we want to do is we want to solve, or not solve, but take derivatives of functions that are in composition form. So f of g of x. If it's of this form, then we know that y prime is going to be equal to f prime of g of x multiplied by g prime of x. Now, we also like to write these things as far as u as well. So you could also write this function as y is equal to f of u, where u is equal to g of x. Then we could say dy dx is going to be equal to df du multiplied by du dx. Now, they mean exactly the same thing. So Newton's notation, Leibniz's notation, but your f prime of g of x is the same thing as df du, and your g prime of f of x is just du dx. So they are exactly the same thing. Most people tend to use this notation more often than this notation. But what's nice about this notation is really forces you to leave the inside function alone when you're taking the derivative of the outside, and then multiply it by the derivative of the inside. So if I ask us to take the derivative of, find the derivative or evaluate derivative, say y is equal to the sine of 2x cubed plus 1. So if I want to take its derivative, y prime, it says to take the derivative of the outside function, leave the inside alone. So the outer function, or f function, ends up being our g function. So this is going to be our f function. F is going to be equal to the sine. And then we're going to multiply by the derivative of the inside function. So the derivative of the outside function is going to be the cosine of, we're going to leave the inside function alone, so this 2x cubed plus 1. And then we're going to multiply by g prime of x. So now the derivative of the inside function, so multiply by the derivative of this function, which is going to be 6x squared. Now we can write this as, we tend to not like to write our coefficient polynomials out here because I want to make sure that you know it's not the cosine of these. It's just the cosine of this 2x cubed plus 1. So if I write this as 6x squared times the cosine of 2x cubed plus 1, then we won't have that possibility of making a mistake to think that that's inside the cosine. Now, if we do the exact same thing for this function using the u as g of x, I can say that f of u, that means y, using this exact same function, I can say y is going to be equal to the sine of u, where u is equal to 2x cubed plus 1. So when I want to find df du, so the derivative of f with respect to u, so df du, it's going to be, df dx is going to be equal to df du multiplied by du dx. So we have to take the derivative of f first and multiply by the derivative of u next. So the derivative of the sine of u is going to be equal to the cosine of u multiplied by du dx, which is going to be our 6x squared. What this forces us to do is not to change the function inside, that your u is left alone when you're taking the derivative of the outside function first. So the cosine of u being equal to this 2x cubed plus 1. So this is equal to the cosine of 2x cubed plus 1 multiplied by that 6x squared. And of course, we rewrite it like this. Now, most people tend to use this, and that's what I'm going to fall back to for the rest of our examples. It's quicker. Just make sure to don't mess with u in the beginning. a. Y is going to be equal to the square root of 2x minus x squared. So notice that my outer function, my f function, is the square root function, where the 2x minus x squared is going to be the same thing as 2x squared raised to the 1/2 power. So when I want to find y prime, I have to take care of the outside function first, which is the radical function of the 1/2 power. So the derivative of 1/2 power is going to be 1/2 power to the minus 1/2. Remember that we leave the inside function alone at first, derivative of the outside, evaluated at the inside function, multiplied by, now we take the derivative of the inside function. So the derivative of this is going to be 2 minus 2x. Now rewriting into its radical form, I'm going to have 2 minus 2x. This 2 is in the denominator, and this power is also in the denominator because it's negative. And negative 1/2 power means square root at the bottom. So this is going to be the square root of 2x minus x squared. Now I can factor a 2 out of the top and a 2 out of the bottom. So this will be 2 times 1 minus x squared, all of that 2, square root of 2x minus x squared. So those 2's will cancel. So this is 1 minus x, all of the square root of 2x minus x squared. So identifying the outside function and the inside function are important. So the outer function being the secant, so that's your f function, and your g of x being composed as 5x plus 1. So when I want to find the derivative of this, remember that the derivative of the secant of x is equal to the secant of x tangent of x. So the derivative of the secant is going to be the secant of x times the tangent of x. Now remember that your input, your x in this case, is going to be this 5x plus 1. So remember, we leave the inside function alone. Now we still have to multiply by the derivative of this inside function, which is going to be equal to 5. So the way we'd write this, just to make sure that that doesn't look like the 5 is inside this tangent, is 5 secant of 5x plus 1 tangent of 5x plus 1. If I want to take the derivative of the natural log function, and remember your outer function being the natural log function, we have to take the derivative of the outside before we take the derivative of the inside. So y prime is going to be, well, the derivative of the natural log function is going to be 1 over its input. So this is going to be 1 over its input being your sine of x. So the derivative of the natural log of something is going to be 1 over that something, but I still have to take the derivative of the inside. So this is, f prime of g of x multiplied by g prime of x. So the derivative of the sine function is going to be equal to the cosine of x. So you can see that this will simplify to the cosine of x over the sine of x, or we can say this is the cotangent of x. Now the e function is a little different. We have to be careful because of what the outside function and what the inside function is. Like, what is your f function? Remember that the input to exponentials is your exponent. So that means the outer function here is your e function, and the inner function, which is your g of x, is going to be your 7 of the x. So if I want to take the derivative of this, y prime is going to be equal to Well, the derivative of e to the 7x is going to be, well, the derivative of e to something is going to be e to that something. Now we still have to take the derivative of what's inside, so the derivative of 7x being 7. So this is 7 e to the 7. Now what I have is I have a polynomial composed with a polynomial. So the reason I bring this up is because this is different than what we had with the exponential. And here the base is the outside function and the exponent is the inside function. Now for polynomials, the outside function is going to be your 9 and your base is the input. So if you ask, this is of the form y is equal to u to the 9th power. So, this being your input, this being the function, as opposed to this being your input and this being the function. So the derivative of something to the 9th power is going to be equal to 9 times that something to the 8th power. Remember that we leave the inside function alone at first, so x squared minus 3x plus 1. Now we still have to multiply by the derivative of the inside function. So this is going to be 2x minus 3. So that is its derivative. Of course, you can put the 2x minus 3 in front, but this is really fine as it sits. Now we can incorporate this chain rule inside things that might have product rules or quotient rules and so on. So what if I ask us to take the derivative of y, which is equal to 2x minus 5 to the 4th power multiplied by x squared minus 5x plus 3 to the 5th power. How do we do something like that? Well, what this is this is a product rule because there's a product here. This being your u function and this being your v function. So you know that if we're talking about a product rule, that if y is equal to u times v, then y prime is going to be the derivative of the first times the second plus the first times the derivative of the second. But u, this function is a function composed with a function. This is also a function composed with a function. So when I take its derivative, I have to do that chain rule. So the derivative of the first is going to be 4 times 2x minus 5 to the 3rd. That's the derivative of the 4th power, multiplied by the derivative of the inside, which is going to be 2. Now times your v function, so times this function, which is x squared minus 5x plus 3 to the 5th power. So that takes your u prime v, plus your uv prime, so 2x minus 5 to the 4th power, multiplied by the derivative of this function, which is going to be outside function first, 5 evaluated at the inside, multiplied by the derivative of the inside, which is going to be equal to 2x minus 5. So this is u v prime. Now we can simplify these things. So 8 times 2x minus 5 cubed, x squared minus 5x plus 3 to the 5th, plus 5 times 2x minus 5 to the 4th, to the 5th, because I have another one, times x squared minus 5x plus 3 to the 4th power.